Let's practice a little bit of balancing. Here are 3 different simpler balancing problems for us to start with. If you'd like to try them on your own and then go through, you could pause the video and then try these and then see whether you get the same answers as I do. Let's first take a look at the first problem. So we have water, H2O, liquid, breaking down into hydrogen gas and oxygen gas. First, I need to determine the number of elements on each side. So I have, as it's written, I have 2 hydrogens and 1 oxygen on the left. On the right, I have 2 hydrogens and 2 oxygens. Notice our oxygens don't match, so I need to have 2 oxygens to match my 2 oxygens on the right. So I'm going to just put a 2 here for my coefficient. So I have 2 water molecules now. That's going to change my oxygens to 2, but it's also going to change my hydrogens to 4. So I have 2 H2Os. Each one's got 2 hydrogens, so 2 times 2 for 4 hydrogens. On the left, so that's on the left. That means that I've got 4 here. I only have 2 on the right, but I can fix that by putting a 2 here as well. 2 times 2, 4 hydrogens. Let's take a look at, we always double check. 2 times 2, 4 hydrogens, 2 times 1, so sometimes you might want to write it in 1. 2 oxygens, 2 times 2, 4 hydrogens, 2 oxygens. So remember, if we don't have a coefficient, we assume the coefficient here is 1. Let's take a look at the second question. Nitrogen gas plus oxygen gas forming N2O5 gas. We have 2 nitrogens, 2 oxygens on the left. On the right, we have 2 nitrogens and 5 oxygens. 2 and 5. Well, there's no number that we can put in front of O, so in front of the oxygen, to make these equal. So we need to look at our lowest common multiple. So lowest common multiple. So what's the lowest number that both 2 and 5 go into? So 2 and 5, so the lowest common multiple of 2 and 5 is 10. So we're going to need to have 10 oxygens. To get 10 oxygens, I need to put a 2 in front of here. To get 10 oxygens on the left, I'm going to need to put a 5 in front of my O2. So my O on the left, I'm going to have 10 oxygens on the left. On the right, I'm also going to have 10 oxygens, but I also changed my nitrogens here. 2 times 2. It's going to give me 4 nitrogens. Since I have 4 nitrogens on the right, I need to have 4 nitrogens on the left. So I need to put a 2 in front of this one. So now I'm going to have 4 nitrogens on the left, 10 oxygens. 4 nitrogens on the right, 10 oxygens. Okay. So always double check. And you'll check and see, is there a lowest common multiple that these values can go into? The last example, we have hydrogen. There's 1, 2. So sometimes we have elements in more than one place. We'll look at different things that we do with this type of compound later. Chlorine, I have 1. Na, I have 1. And oxygen, I have 1. Now let's check my elements on the right side of the equation, on my products. I have hydrogen, I have 2 hydrogens. Chlorine, I have 1 chlorine. Na, I have 1 Na. And oxygen, I have 1 oxygen. Wait a second. 2 hydrogens, 1 chlorine, 1 sodium, 1 sodium, 1 oxygen, 1 oxygen. This equation is already balanced. The reason I include this is because it's very common for people to jump right into changing coefficients without checking, is this actually balanced? In this case, it is. And so there's no more balancing required. It's correct as written. So just to summarize, it's the answers for the 3 different equations.